Hello, it's PvPisostratus. You may have noticed that I haven't been making videos in quite some time. I've kind of taken a little break of the content producing to focus on the code behind the model that you're about to see today. And so with that, we have updated the Great League and Master League ranking pages here at sylph.gg and under PvP resources in the Great League and Master League. Of course, I'll link both of those in the description. But essentially, this is a completely different model than the original one, and in my opinion, genuinely the state of the art in team of 3 Pokemon battles. And I'll explain why I think that, and of course the assumptions that are made in this model, because every model is going to have assumptions. But I think that these are much more reasonable than, say, the original model that we had. So, without further ado, let's get into it. So, Pokemon Go random battles. So, we do have to talk about assumptions in this model. And I'm going to tell you right now that any model that I create is going to have assumptions. And generally speaking, any model is going to have assumptions. This is a quote from famous statistician George Box. And as he points out, these assumptions are not going to be exactly true. The goal here isn't to make a perfect model. It's not to make a right model. It's to make a useful model. And that is, I think, what I have accomplished today, though there are, of course, steps forward to make it more useful. So, changing assumptions. So on the left here, we've got assumptions that were made with the original model. If you haven't seen that video, I encourage you to check it out. It is an interesting model and very useful for what it does. But I think that this one that I've just made is a little bit better in a number of regards. So first 2 assumptions here are actually exactly the same. So the order of the second and third mon do not matter, but the lead does. It's mostly important for interpreting the results shown on sylph.gg, but also there are very minor changes in the battles themselves that do rely on the order of the second and third mon in interesting ways. Secondly, only Pokemon with their PvPoke recommended movesets make up the meta. Now this is one of the major criticisms of the first model. It's definitely something that I'm working on. But right now, it becomes too computationally expensive to include multiple movesets per mon because they essentially have to be modeled as their own Pokemon unless I do something really clever. So for right now, we're going to keep that assumption the same, but that's one of the big levers I want to pull on this model. This assumption here, that battles can be approximating using their individual PvPoke battles and 3 single shield, like 1v1 shield matchups, without any switching. That is the original model. That is extremely computationally cheap. I mean, it's just a conditional sum averaged together over a bunch of different battles. But generally speaking, not the best approximation that can be made of a 3v3 battle. The new version approximates these battles by randomly making decisions across all known game mechanics. So that includes having 2 shields, includes fast moves, charge moves, switching, doing nothing. And that includes even larger strategies like sack swapping and a whole host of other different mechanics in the game itself. And all of those are randomly chosen. And finally, the initial assumption from the first model was that the meta could be approximated by weighting each team equally. Now obviously this isn't the case, but it was the best data that we had at the time because we had no data at the time. But now we do. With the advent of Project Indigo League, we now have data as to which teams appear in Go Battle League. And so we can use that to weight the teams that we're facing. And so that's a huge change there as well. So going back into the random battle algorithm itself, as we can see here in this flowchart, essentially what the program does is it constructs the teams based on what you input it, and then it starts the battle. At every point in the battle, it checks whether, it's done. Have all 3 Pokemon on the other team fainted? If so, it's going to calculate the score and then add that to the battle data that's being calculated. If it isn't over, then each team is going to make a decision simultaneously or near simultaneously, but without any information about what the other team is doing. And they will choose to either do nothing, do a fast move, do a charge move, do the other charge move, or do a fast move and a charge move at the same time, which is really more like collecting the damage and energy from a fast move and sending a charge move on the same turn. That's kind of what under tapping is. And then they can choose to switch. Now, of course, these are conditional. You can only switch if you have a recently fainted Pokemon or your switch timer is down, or your switch timer is ready, rather. You can only send a charge move if you have enough energy. You can only collect the energy and damage of a fast move if your fast move cooldown is over. In most cases, you can do nothing, but for these random battles, we are not allowing the teams to do nothing if they have a fast move available, which is just kind of a way of ensuring that the players are reasonably skilled. The Project Indigo League data. This is also shown on the Silph.gg page, as shown here. And so this is the meta that these teams are playing against. They're not playing against each other. They're playing against exactly the teams as they appear in the Project Indigo League data. And that's a huge change that I think really helps to bring this model much closer to reality, much closer to usefulness. So, yes. Finally, there are still some mechanics that are not included. You notice I didn't have anything about the timing of that switch. Forced switches, you are allowed to choose how much time you want to take during that switch, which can affect your opponent's switch timers and the eventual timeout. But that's not implemented here right now. That's a very soon in the future thing to implement as well. Undercharging is interesting itself. I'm not sure how it would help the random players because they are not making strategic decisions, but it's definitely important to include in the model for strategic players, this kind of undercharging idea, which is essentially not popping all of the bubbles in a charge move. And finally, timeouts are not included right now. It's interesting. It's a little difficult to implement, again, more for a strategic player than a non-strategic player, because the actual reward function, the who wins in the battle, is different. It's a different way of looking at it than if you had no timeouts at all, because then I can just use the health of the mons. But timeouts are weird. It's the number of Pokemon that have been killed or have been fainted, and then the HP percentage of the mon that is currently in. And so that's just a different incentive entirely. And so incorporating that as well is going to be a little difficult, but definitely something I'm going to be doing soon. And so those are the major mechanics that I see this model not including right now. And those are coming soon, but there are still some missing mechanics in this model. So how good is random battles? How good are random battles at approximating an actual battle score? Well, to do that, we can compare to an actual strategic battle. So here we've got a team in the Sorcerer's Cup. That is important for imperfect information later. We'll get to that. But essentially, the team here is Wigglytuff, Frostlass, Skuntank versus Noctowl, Alolan Toxicroak. And so with this one line of code here, we can get 10,000 battle scores and take their average. And so as you can see here, the average battle score here is 0.525. So on average, the Wigglytuff Frostlass Skuntank team will win here, and it won't win by very much. We can then play out a strategic battle. Now note the time difference here. These only take 4 seconds, and that's with 10,000 battles. This takes 100 seconds, and that's 1,000 battles per turn. And so it's a lot more computationally expensive to do this strategy, and that's not why we're not using that as the basis of the model itself, because that would be great, but also too expensive. And so we can look at the actual score that the strategic player gets, which is represented by this blue line here, where it ends up right here when that last mon faints. And this green line here is the random battle score. And as you can see, it's a pretty good approximation. Finally, we can include imperfect information, so this version doesn't know the Pokemon that the opponent has until they revealed them. And again, it's a pretty similar battle score at the end. Now, what I've found running multiple ones of these, and again, at 90 seconds or 100 seconds per run, there's not much aggregate data I can get from these, hence why we don't use it for the overall rankings. But from what I've seen with the sims that I have run, the random battle scores are good approximators of the perfect information battle scores, which are usually, in most cases, good approximators of the imperfect information battle scores. Now, there are a number of things we could go into here, and they're the subject of a number of videos that I want to make, but I will include those in a separate video, because right now I just want to focus on the GBL team rankings themselves. And so, now you know the actual model behind this. It's explained here in very low level of detail, just kind of a quick explanation. But this video kind of serves as a more in-depth explanation. And if you really want to get into how the model works, or maybe to give some suggestions, first of all, suggestions can always go in the comments of these videos or any of my posts on, say, Reddit or whatever, and I will read those and see what changes I can make. But additionally, you can look at the code itself. So here we've got the actual model here. This is quite larger than the original one, so I've broken it up into multiple different files. You can see we've got say a constructor for the Pokemon themselves based on a number of different things that you could input. You could input a string of its name or its number in a particular ranking. We've got this code that accesses the Sylph API to get a particular meta. Again, make sure that you only call this you call this less than 10 times in 10 minutes, which shouldn't be that big of a problem. Just put it outside of all of your loops. You can look at the actual mechanics themselves. So how is damage calculated according to this model? How are fast moves evaluated? How is CMP decided? How are buffs applied? That kind of thing. All included here. And then, let's see, we've got the battle logic itself. So this is how we decide which decisions are possible. This is how you play the decisions. That's how a turn is done. So it makes the decisions before anything else happens. And then it evaluates the switches, and it evaluates the fast moves, and it evaluates the charge moves twice in case there's a CMP tie. And then it steps the timers. And then it goes on to the next state. Here's where it decides whether or not the battle is over. So all of that is included in this code here, and I'm more than willing to answer any questions about this. You can make suggestions to the code itself, in the GitHub repository, which is available to everyone now. I'll be sure to add this link to the description, but essentially all of my code is here, and you can add an issue. If you see a problem in the code or have a suggestion as something to change, you can pull request. You can actually change the code itself and give me that as a suggestion. All sorts of lovely things that you can do here. And so all of that is freely available right here. And finally, what is the actual thing that runs the rankings look like? It's actually really simple. So this is, for instance, the Great League rankings. You're going to need your own information for the information that is provided by Project Indigo League. That is not at this time, or I don't know of any plans to ever make it for public consumption. But yeah, so you're going to have to find your own data for that, or make up your own, make some predictions, see what that kind of shows up as a meta. You just provide it with a file name to leave it as, the league that you want it, and using the top in mons. And so each of these rankings were constructed using the top 35 PvPoke ranked mons. It will tell you if it ignores a team. Say, for instance, if you have a team that is clearly somebody trying to level down by using a Togepi or something, then it will just ignore that entirely. And then it'll give you a nice progress meter. As you can see, this took 16 hours to run. And you can even do interesting things like this is the number of battles per set that you can expect to win for all of these teams as a histogram. So you see there are very few teams up here that are these very high rankings. And those are the teams that you see here. But on average, things are pretty down the middle, which is interesting. I think to me that indicates that people are playing the meta well. Like the meta that people are constructing is really good at balancing the game. And so that's some interesting results from that. Finally, how do you interpret this data? It's an important question. So this is estimated battles 1. Assuming players are of equal skill, these are the number of battles per set that you should win. Now, it's obviously not going to be every time 3.67 because you can't win 3.67 battles per set. But on average, law of large numbers, it should be around there if this model is correct. And I generally have good faith in this model. This is your average health score. So these are still really close battles. This isn't like a team that's going to stomp everything you see. 0.56 is not very high. This is essentially the PvPoke score, but instead of going from 0 to 1,000, it's going from 0 to 1, and instead of being for individual battles, it's for teams. We can also take a look at the movesets themselves. Again, these are just the PvPoke recommended movesets. Definitely still working on that. And for convenience, we've added the move costs there as well. Note that these are not sorted in the raw way that the information from my model comes out. These are sorted by lead. So that way you can quickly navigate through. If you want to use Registeel as a lead, these are some good teams with a Registeel lead. If you see a mon like Altaria here that is just heavily populating the second or third slot, and the same thing with Galarian Stunfisk, that indicates to me that for a wide variety of leads, Altaria and Galarian Stunfisk, in many cases together, are really good second and third slot Pokemon. And so there's some information you can gather from even just the way that these pages are structured. Again, you can see the Project Indigo League data that all of this is based on over here in the popular teams tab. So that's pretty much how the new model works. Let me know what changes you want to see in the model next. I have been reviewing feedback that a whole bunch of you have sent over the time in which the first model was published. And I think this new model really helped to address a number of those concerns. And so let me know what you think in the comments or on the GitHub repository. I'll be sure to link everything mentioned in this video down below. And if you haven't already, like and subscribe, since I will be making more of these videos relatively soon. Thanks.